Hi everybody. So here we've got a grade 9 GCSE question on calculating with the limits of accuracy. We're told that the time period in t seconds of a simple pendulum of length L is given by this formula. And Katie uses a simple pendulum in an experiment to estimate the value of G, this G here. And we have these results. So L is 52.0, correct to 3 significant figures, and T is 1.45, again, correct to 3 significant figures. We need to work out the upper bound and the lower bound for the value of G. So we can begin this by working out the upper and lower bound for each of these measurements. Do you want to give that a go yourself and then come back when you're ready? Okay, so to work out the upper and lower bound for L, we're told it's correct to 3 significant figures. So if we draw a quick number line, we're told it's rounded to 52.0. So to 3 significant figures, this is between 52.1 and 51.9. So the upper bound would be halfway between these two. This would be 52.05, and the lower bound would be halfway between these two, and this would be 51.95. So we can say that L has to be less than the 52.05, but greater than or equal to 51.95. So this is the upper and the lower bound for L. For T, by doing it in green, I'm just going to move this up a bit. Again, we'll draw the number line. We're told it's rounded to 1.45 to 3 significant figures. So what two values do you think it would be between? So to 3 significant figures, it's going to be between 1.46 and 1.44. So the upper bound would be halfway here, 1.455, and the lower bound would be halfway on the other side, 1.445. So T must be less than the 1.455, but greater than or equal to 1.445. And these are the upper and lower bounds for T. So the next part of this question is to make G the subject of this formula. So do you want to give that a go? And then we'll combine what we've done here with the rearranged formula for G. Come back when you're ready and you can compare your working with mine. Okay, so how did you get on with that? We know that T is 2 pi times the square root of L over G. So to make G the subject, I'm going to take 2 pi to the other side. So we'll get T over 2 pi divided will be the square root of L over G. And now we need to cancel out the square root. So we'll square both sides. We get T over 2 pi squared will be L over G. And now to make G the subject, I'm going to begin by moving it over to this side so it's no longer a division. So we'll get G times in both sides by G will be multiplied by T over 2 pi squared to give us L. Now to work out G, I'll divide both sides by this term. So G will be L divided by T over 2 pi squared. And this is the rearranged formula for G. So the next part of this question is to work out the upper and the lower bound for G. So think about which of these values would give us the upper and the lower bound for G. Do you want to try and work out the upper bound? You can pause the video and come back when you're ready. Okay, so I'll come back if you had a go. So the upper bound for G, well, we want the maximum possible. So this will be the maximum L, the upper bound for L, so on this value here, divided by the smallest possible denominator. So we want the smallest possible t, we'll use this t. So we'll use the upper bound for L divided by the lower bound for t. And if we substitute both of these into our new formula, we'll get the 52.05 divided by 1.445 over 2 pi. And this is all squared. Now we can work this out on our calculators. When we do that, we get 984.1 to 1 dp. Now do you want to try and work out the lower bound? Think about how that might be the opposite of what we have here. Again, you can pause the video and come back when you're ready. Okay, so welcome back. So to work out the lower bound for g, we want the smallest possible numerator, so a lower bound for L, divided by the greatest possible denominator. So we want the upper bound for t. So a lower bound for L divided by the upper bound for t. And then we can substitute these two values back into our formula, and that will give us the minimum g. So we'll get 51.95 divided by the 1.455 over 2 pi all squared. When we work this out, we get 968.7, again to 1 decimal place. So I'll say that g must be less than the 984.1, but greater than or equal to 968.7. Okay? Well, thanks for watching. If you want any more practice with the calculations with limits of accuracy, you can download the lessons and the worksheets from my website, mrmathematics.com. I'll leave a link in the description below.